So hello everyone, welcome again to today's webinar focusing on the new feature set of our facial recognition platform SmartFace. The webinar today will be divided into two parts, the presentation itself with the live demo and afterwards the Q&A session. The presentation will take approximately 30 minutes. As usual, you are more than welcome to take the active part in the webinar by asking questions. Feel free to post them anytime in the Q&A tab on the bottom of your screen. We will try to address them immediately, and more complex questions will be addressed during the Q&A at the end of the webinar. There's no need for you to take notes as the webinar is being recorded. We will be sharing the recording with all of you in the follow-up email tomorrow. In case you feel that you need to discuss some of the topics addressed today in more detail, don't hesitate to write us an email at sales@innovatrix.com or contact directly your sales representative. Finally, I'm happy to introduce our presenters today. Here with me are today Peter Martisch, our CSO and Business Unit Director of SmartFace, and Robert Isaac, our Channel Manager. Before I pass the word to them, as usual, I would like to open a short poll that will help us understand our audience today. Thank you very much for participation and enjoy today's presentation.
Thank you very much, Janka, for the introduction. And as you can see also, there is a poll available, so do not hesitate to answer a few simple questions. That will also help us a lot in terms of building the roadmap, as well as prepare the right proposition for you. What is the agenda for today? Over the next 25 minutes, we will introduce shortly the SmartFace version 5. We will introduce what are the main challenges of the security for preemptive use cases, including the security in real-world scenarios, scalability and hardware footprint, watches and notifications, and how to build your custom strategy, security strategy overview, and also how to solve rapidly many security incidents that might happen over your premises or over the public spaces. And at the very end of the presentation, we will also showcase how you can use very different peripherals like smartphones, smart glasses, in order to provide identification directly on the go without the need of deployment heavy infrastructure. Innovatrix is on the market more than 50 years.
Somebody is.
And we believe in a world where people can instantly trust other people by relying on the right technology, biometric technology. We are independent, we are experienced, and we also support our partners in terms of delivery, trainings, as well as education. We are based in Slovakia, sharing the R&D with Czech Republic, Brno, but we have the teams all around the world. Team sitting in Latin America, approximately 6 colleagues. The same, we have an office in Singapore, colleague in Taipei, as well as a team based in Riyadh, Saudi Arabia. Currently, we have more than 150 employees, and we can support various modalities, including fingerprints, irises, face, palms, plus we have our own proprietary OCR engine to support also various use cases for remote identity verification.
I believe it's 166 employees as of today.
Okay, 166. So yes, we are growing, and we are really happy that that technology has its usage in real life. So far, we have deployed more than 500 projects over 80 countries. And with our partners, I would like to introduce also a few key references from the last few years. The first place is the Indonesia Criminal AFIS, with the database almost 2 billion records, considering that majority of users have 10 fingerprints and face. Another very nice reference is the border control of Saudi Arabia, where we support fingerprints and border control processing. The same with, for example, we were enrolling the voters in Guinea elections last year, or home credit from the Southeast Asia, which is the biggest microloans provider, using our technology to remotely verify approximately 100,000 users that apply for loans. So this was a short introduction of the Innovatrix, and now I will give a word to Peter, our sales director, to give you a little overview of the story of the SmartFace.
Thanks, Robo. So it is really my pleasure to introduce SmartFace 5 today, or our pleasure. As you can see, the whole journey started in 2018. So that's what, almost 4 years ago. And the idea of SmartFace, the initial motivation was to package our very accurate facial identification algorithm and provide its functionality on top of the video files. So we wanted our customers to be able to leverage our very accurate facial identification and process RTSP streams or video files coming from the cameras typically in order to provide all kinds of functionalities. And our focus at the beginning was really to have a very strong and robust engine that scales with a very well-designed API. And we were expecting our partners and customers to basically take this engine and customize the front end and prepare the user interface based on a specific use case. We have had several customers that have done this, but it was really a dozen, not more. They were focusing on different verticals such as retail analytics, where SmartFace was able to count unique visitors and do demographic analysis such as gender, age. We've had customers doing or building an access control platform on top of facial recognition powered by SmartFace. But all in all, it turned out to be too much of a black box in terms of a platform. So it wasn't really a finished product. It was kind of a very robust SDK or framework. And the effort needed to make it into a production was significant, and companies turned to a more finished or ready to deploy solutions. So we said, okay, let's bring it to the next level. We will keep the robust API, we'll keep the architecture because it scales very well, but let's pick one vertical or one use case, one problem to solve, and build the entire tool set around it so we can deliver and deploy the solution directly to the end user premise. We have picked access control. So, and there was a series of webinars about SmartFace version 4, 3, and 4 that was really focused primarily at seamless access control. Seamless being users don't really need to interact with any device. They just walk through the gate, walk through the corridor, the camera sees them from far away, and we recognize reliably the person, even though they may be wearing a face mask, and we open the door without person even stopping. That was the idea, and we actually have had quite a success with this solution. We've been deploying it all over the planet, primarily in the new modern A+ business center buildings. And that vertical is still alive and is still growing our partner network, and we have customers and partners deploying access control based on SmartFace. And then we figured, okay, this is a great lesson learned, and SmartFace has matured into a product that's proven in the field. Let's now tackle the most difficult and most complex subject where it comes to facial recognition, and that is public security / surveillance / video analytics with facial recognition. And that's where the SmartFace 5 comes in. And this is something we are proud to announce. The SmartFace version 5 is basically coming with a whole new feature set and tool set that is designed towards the public security use cases. So essentially being able to detect and identify people of interest in any video sequence or video file or video stream and provide early warnings so this feedback can be actionable and we can basically prevent an incident. So this is a brief story of SmartFace, and it really is still the same very robust engine with more and more user tools that are actually focusing on solving a specific problem. So yes, we call this a preemptive security. Why? Because we are trying to deliver a solution that is actually notifying you about an incident before it actually happens. So we are trying to focus right now on the real-time identification and detection. So you or people that are responsible for security are notified fast enough to do an action. Now we are also one of the big focus of ours is biometrics engine ABIS, and we also are looking into the video investigation, which is a different scenario. The incident has already happened. You have all kinds of footages from the crime scene, and you need to analyze patterns, people, movement, suspicious behavior. That's something we are looking into as well. This one right now is really focusing on real time. So yeah, the typical security challenges when we talk to our customers, and we've been actually visiting different surveillance centers, smart cities, command and control centers, police, municipalities. There's various use cases where facial recognition is basically providing an added value and increasing the security in the public premises. Some of the biggest challenges, and we've been really focusing hard on addressing these, is detect faces in parallel faces, multiple faces in multiple video streams. Facial detection as such is a task that is quite resource heavy. And if you imagine you have hundreds of video streams and there's multiple faces in each of these streams and you want to do all this in parallel, that is not easy thing to do. And we have been focusing hard on optimizing our facial detector and neural network architecture to provide as much of a performance as possible. Also, when it comes to successful identification of people in the videos, you are typically dealing with low quality, uncontrolled images. So people do not comply. The cameras are often positioned in the different locations, and the quality of image that you are capturing and trying to identify is typically not ideal. And so luckily we have a very accurate facial identification algorithm that has been trained and works with these kind of faces. So we can proudly say that our ability to identify people from low quality videos is one of the most accurate algorithms or engines that are available. Also, watch list, which means list of people of interest that you're trying to identify. Oftentimes there are thousands, hundreds of thousands records, and obviously with the growing size of the watch list, the accuracy may be impacted. So we have actually managed to create an algorithm and identification method where we can literally have million faces on the watch list and we can deal with them with a very high accuracy. And of course, the notifications. So any feedback that the solution detects needs to be actionable, and you need to be, or the security people need to be warned and alarmed about the specific event or incident that is happening. And you only want to be alarmed about those that you're interested in. You don't want to be overloaded with different events or messages that would just confuse the security people. One important thing, and this may be a little technical, but we are extremely proud of this, so I would like to describe the architecture, is that we have approached this whole architecture setup through the edge computing, or edge to cloud, if you will. So not only we can, on the input side, we can process different video sources, not only IP camera streams. It could be a video file, could be an image or a file or video stream coming from a tablet, or could be an image coming from a smart glasses. Robert will show you the demo of this at the end. Then we have a central processing unit, the brain of the solution. And obviously this can be residing, or it can be talking to a cloud where the aggregation is taking place, reporting and management. Now, it looks quite simple. And in a normal environment, when we talk about video analytics architecture, what's happening? You have a video stream. This is a footage from an airport, CCTV camera. And you have a server architecture, server environment, could be on-premise or in the cloud, which is essentially, when it comes to video analytics, we're performing these four key tasks. First off, we have to decode the video that we are receiving from a camera. Then we have to look for objects and faces. So we are performing detection. Then once we find faces, we have to extract so-called templates. So we have to calculate or compute a mathematically unique number that actually describes the uniqueness of a human face. And eventually we have to perform matching or identification. So this template of a specific person, we're going to look for or compare against all the templates on the watch list. Now, the architecture, such as this one, is amazing. And the way this works, typically the video stream is fed directly from the camera to the central server side or server system. And obviously, since this is a full video feed, the requirement for the networking bandwidth is quite high. It's typically about 2 to 4 megabits, depending on the quality and frame rate. it's essentially similar as if you were watching a Netflix at home. You have to get this whole stream to be able to see the whole movie. In this case, the camera has to send the whole stream to the server, where the server is basically breaking the video stream into frames and looking for specific things as per those events there. Now, what if we want to scale up? We need to add more cameras into the system. So one camera that consumes about 4 megabits of bandwidth, and then we have a server architecture that basically performs all these tasks. And with the growing number of cameras, not only we are increasing requirements towards the bandwidth of the data connection, but we are obviously also asking for more and more resources from the centralized server. So at some point, we will reach a maximum allowed performance. We will reach maximum number of cameras connected to one machine. It could be easily 100 cameras per server, a very robust server, but there are limits. And so not only there are limits on the server side, because it's quite easy to add more server resources, but typically the bottleneck tends to be the connection, the bandwidth. If you have a smart city with 10,000 cameras, all these 10,000 cameras connected to one centralized dispatch center and being sent through the video analysis, that can be really challenging from the bandwidth perspective. So that's why the typical surveillance center, command and control center, or smart city observation team, they have several operators that are essentially switching through the cameras and trying to identify a suspicious activity by a naked eye, manually, right? Because given the infrastructure before, there is only so many cameras the video analytics system can process. Typically, it's about 10% of the overall number of cameras. So let's think of a city of Berlin, where you have close to 10,000 cameras. About 1,000 cameras can actually be processed by video analytics. The rest of them need to be monitored by human beings, which is typically impossible. And that's why the security reacts only after the incident has happened, because we missed it. Now, let's look at this picture again and see what we've done with it. We disconnected the camera. We put a little device, which is called an edge computer. It's essentially, and we have it here, this is a NVIDIA Jetson in the enclosure that's basically fit for industrial purposes. There are no moving parts. There is no hard drive, no ventilator, no nothing. It's just a metal box with a bunch of silicon components in it. And this little thing is actually serving as a mini computer that can be deployed in the field. So the camera is then sending the video feed to the device. And what we do, we offload some tasks onto this little machine. So rather than having a central huge server doing all the tasks and activities, we basically have this little boy on the device, this little gadget, doing video decoding and face detection. So the big feed goes from camera to the little device, which sits typically very close to the camera in the field, in the city, in the distribution box. And then the device is basically analyzing every single frame that comes out of the camera. And it's basically looking for, in our case here, for faces. So we basically just detect the faces right here on the device. And once we detect those faces, we send them to the server. So instead of full 4 megabit data stream with all the frames and videos, we only send a very small amount of data, which is pre-processed. So we detect the faces, we crop them, we attach some metadata, and we send it to the server. Normally, this all would be happening on the server side, but with the edge approach, we are doing this on device, and we can basically distribute this as many environment cameras as we want. And not only this basically saves a ton of bandwidth, so the data output from this device to the central side is minuscule. You can see it's 100 kilobytes per second on average, depending on the number of faces, etc. But also the server capacity is able to handle significantly more devices of this sort, because the amount of work the server has to perform is reduced by half at least. Now we can basically scale this up. Not only we can handle one camera of this device, we can go up to 4 cameras. So this little gadget can basically handle 4 different cameras in the corner in the smart city or street. And then we process all these streams, and we actually, again, only send our crops to the server and dramatically reduce the requirements for the bandwidth. Now let's replace an image of an actual product with a symbol. This is a symbol for edge device, apparently. And so we can draw up the possible architecture. This way, we can basically do so-called cascaded architecture. So we can have cameras in the field. We can have tablets, mobile phones, smartphones used by the official security people in the field. We can have smart glasses feeding the little signals and streams into the edge devices that do the pre-processing. We can combine and cascade edge devices with regular servers, and it all ends up being pushed into one central site. This way, we can basically build an architecture that has virtually unlimited number of cameras because we distribute the load and we basically do the whole cascading processing effect. This is really something that's been a lot of effort. It brought us to supporting Linux, embedded Linux, and it actually not only helps you to save money on the infrastructure, because rather than having one huge server, you can buy a bunch of these devices and distribute the traffic, but it also makes the large-scale deployments possible from the bandwidth perspective, because the amount of data being pushed to the central site is dramatically reduced. Also, from different perspective, all those tasks, spatial detection, extraction, matching, essentially the math behind being able to identify face from the video stream and against the watch list, those tasks are resource heavy. Those are typically machine learning convolutional networks. It's neural network processing. So in order to accelerate this calculation or computation time, we typically would use GPU, graphical processing unit, which is a special card that does a lot of floating point operations in real time and can actually help to expedite the actual execution of the neural network dramatically. And we obviously do support the GPUs. We can have them in the server and perform more process more cameras in the server. But, and this is important, GPUs, as we know, are basically in shortage. It's not easy to get hold of professional GPU cards, not even, let alone the gamers cards. So we have an engine, or our approach to processing the video stream is basically bimodal. So we can leverage the GPU if you have one. If we don't, we can perform the exact same task and with the exact same accuracy by the CPU only. So if we are unable to purchase the GPUs, we don't really care, because we can perform the whole video analytics functionality just by the CPU. And as you can see, yes, it is twice as long, even maybe even a little more than GPU duration, but the all-in-all process duration for facial detection and matching is within in 141 milliseconds. So it's still feasible. In other words, it's not just like saying we can do facial identification on CPU only, but it's only for 4 cameras, because we can actually scale up pretty well without a GPU.
I will just add that very often when talking to our partners and customers, they keep asking us, one of the very first questions, like, how many GPUs do we need in order to support our use case? And the use case is very often like, we call it either light or medium, considering several faces per second, like common security use case where you monitor the corridor, the hall. And very often they're surprised that when we tell them, no, you don't need any GPU at all, because majority of tasks can be done on CPU level. Really depends on the use case. So this is also our very first question. Try to describe your use case, especially in the peak time. So with just CPU setup, you are very well deployed for common use cases with medium traffic. Consider approximately 5 faces per second, because within just 1 second, you can process at least minimum 6 faces. And of course, if your use case requires really high traffic, and consider like public spaces, train stations, subways, where you have a crowd, then we recommend the GPU. And at the end, I would like to also mention that you can combine both on one server deployment. You can dedict the cameras that you know that have a lower traffic, they will be running on CPU, and you may have one or several dedicated cameras that you expect a very high traffic, and the processing will be shifted to the GPU graphical card. That was the hardware and scalability footprint introduction. And now let me please carry on with the part we will introduce the watch list and notifications. In terms of security and providing preemptive security, it's very important to create your custom strategy. I will introduce on the next slides. To support your custom strategy, which is very typical for your premises, you should be able to segment the users into logical watch lists or galleries, either the positive way, it can be employees, it can be visitors, or in the negative way, that means person of interest, the block list, fraudsters, simply the persons you would like to focus because you have some suspension, you suspect that there might something wrong going on. And what is important to do and create the right watch list that support your custom security is, first of all, we need to display detection and tracking of multiple faces in one frame, in one view of the user. This is not very common when we have seen in the past, but our SmartFace can seemingly support major or multiple faces over multiple streams. Also very important is to get a notification pretty much instantly. As you could see on the previous slide, the matching part is usually the least CPU intensive, and I would like to just highlight that the matching part is always happening on CPU. You can decide if you will switch the face detection and face template extraction between CPU and GPU, but for matching part, we will always use the CPU. And just in general, if you want to search or if you want to get the notifications from the 1 million users watch list, you can get it below 1 second, considering the template, face template extraction, face detection, and the matching. We done the benchmark. It was like 600 to 700 milliseconds on i7 Intel CPU. So with pretty low, or let's say something like a middle level CPU and chip, you can achieve the enterprise level of security. Of course, very important is to display just the relevant notifications. Therefore, we support the custom view per officer, per security officer, which can choose which cameras to see and from which camera streams you would like to receive the notification of chosen details. That means you can see only detected faces or together with identities, as well as you can see the pedestrians. As you will see in a short while over the live demo, this is completely configurable per the security view. In terms of security, very important, it needs to be considered that we have many cameras that simply are not mounted well for face recognition, but still they can monitor large areas, especially for a movement of suspicious person, of soliciting, many use cases that you would like to monitor and be aware. And therefore, we have also deployed the pedestrian or human body detection that can alert you when there is a movement of the person. And of course, very important is to have a accurate identification, even when the users are wearing, the jackets, face mask, sunglasses, especially the face masks are pretty mandatory all around the world. So we have retrained our algorithms last 2 years also to support the face, which is partially covered by the face mask. And what does it mean in reality to create a custom security strategy? As I told you a little while ago, the user or the security officer can choose which cameras to preview and from which cameras to see the notification. So you can preview, for example, 1 or 2 cameras, but you can get the notification from another 20 cameras. And this can be customized per officer security station. What is it good for? Especially that your security staff is not overloaded with non-relevant notifications. They can focus only on important details and react timely. This will lead to mitigation of the risk, and you can utilize your security staff to actively monitor, guard the premises, to be in place, to be visible, and not just by dummy watching the screens and waiting what happens and wishing that we will actually see it. And right now, I will ask Peter to step outside in front of the camera where we are running the SmartFace
demo. Put on the mask, see if you can identify me with the mask on.
As you can see, I can choose from 2 camera previews. On the right side, I will just display another video stream we have in our office. And on the left side, Peter will appear in the short moment. So as you can see, Peter's face has been immediately detected. You can also choose would like to see So from the notification detail, I see immediately this is the biometric score. We support also to switch to linear score to see it in percentages. We provide the metadata about the user, about the time, about the camera ID. So this way you can also track the user and see exactly in which area the user is. And also metadata like gender, status of the face mask, from which watch list the user is. This is very valuable information, as you will see in a while when we will introduce the face search and history preview. On this custom view, as I mentioned, you can choose if you want to see different camera streams according to your layout. Of course, the design is responsive. It runs in the browser, so we support various devices from tablets, smartphone, screens of different sizes. As you can see, we are streaming live, so users are just passing. I will just highlight that due to GDPR, not all of our colleagues are on the watch list. We need to take this very seriously, so we ask for the GDPR consent. Peter gave me the consent, so I enrolled him to the watch list. And as you will see myself also, I'm on the watch list. I will just highlight here that I can see selected cameras. As you will see in the configuration, currently I have approximately 10 cameras ready. So even if I, for example, I can turn on more cameras, for example, this one and this one. And then if I will switch to the security preview, I will get the option also to preview different cameras. So for example, right now I want to focus only on one camera preview to get a notification just from this camera. Peter just appeared, and I want to see only information, for example, of identified users. And this preview responsively reacts to that. So I see only the users that have been on the watch list, that have been identified. So for example, Michal here, or as Peter was a little while ago in front of the camera, for example, here. So this custom preview supports also your custom strategy. If you have 4 officers commonly watching the screens, you can utilize 2 of them to be in the field and just 2 of them listening to the notification when some sort of incident happens. And now we will carry on with the history and face search. History preview is here for investigation and for the solving the security incidents. Very common, for example, you can imagine you will come to the office or to the work, or you just realize that some security incident has happened last 2 years. Last 2 days. And you would like to quickly see all the suspects or what might happen. In common way, you would, if you have just common CCTV, you would have to manually browse and preview many video footages, manually search what might happen, maybe detect people manually, and try to identify them. This is not very useful, especially if you have many camera streams, if you have large video footages, and also if you have a pretty large data set or large gallery of the users. Face search supplements this strategy for history preview and for investigation. You can either trim down the big amount of data, as I will show you in a while. For example, I want to see detected faces from a weekend or from yesterday. But on the other side, especially when security incidents happens, police, security coming with very partial images, video footages from the smartphones, or you can imagine, for example, somebody lost his child in the crowded area. So very often the input for search is just an image of the user, which makes the investigation very, very challenging. By implementing the search phase by image, that means you can just upload one partial image, as you can see on the preview on my slide. We can immediately search hundreds of thousands appearances or faces in the gallery and immediately see the possible matches to the user as well as the camera IDs, and we can track the user and his movement across the premises.
Sorry to interrupt. Critical or very important thing that we should mention is that SmartFace can remember every single face that has been spotted by any of the cameras, regardless of whether it's been identified or not. So if it was on the watch list or it wasn't, as well as every single human body appearance of a person without you actually seeing their face. Every event of this sort is basically logged with all the metadata we collected. So thanks to the very powerful filter and the search and indexing system, you can basically look for patterns, behaviors, movement of people, even though you might not know them, but you still have a very powerful tool to analyze the behavior or patterns or history of a certain camera, location, or person.
Exactly. Very often you don't even know what you are looking for. You're just looking for a suspicious activity for people that do not belong to your organization, to your watch list, and similar hints that helps you to solve the situation. I would like to also mention that on API level currently, and we will release it within a few weeks, we also support faster than real-time processing, again, supporting common security use cases like police officer comes to the shopping mall, shows one image and tell me if this person has been here, let's say, over the last 2 days, which either you can manually preview all of the video footages, or you simply deploy the right solution and you can search rapidly. You can process multiple video footages approximately 10 times faster as it's a real length, and detect the faces, and then process the search across the gallery. And let me show you on the next demo part. I will switch to the history part of our SmartFace. In the history part, we see we have approximately 127,000 records. And on the right side, you have different criteria you can use for your search and history view. Let's start, for example, trimming down by the date. Let's see who was here yesterday, who was we detected here on the watch list. We see detected faces, identified person, detected pedestrian. So maybe let's focus only on the identified person. This will limit again all of the records just to the records where we have the identification match of the user and where we can provide the user's identity. Okay, let it roll a little while. Let's do it one more time. For example, yesterday, and I will try, let's say, detected faces. And here we have all the people that have been detected and do not have the match against the watch list. What does it mean? This way, for example, we could limit the users that were in our premises, and we can exclude the employees or people that belong to the organization because we consider we have them in the watch list. Also, once you have such partial image, you see also the details about the date and time, camera ID, and details like gender, the age, and many other metadata that can help you to investigate. In terms of face search, I can also grab this image. I can use it for the searching directly and show me just matches of this person across the history view.
So what Robert just did, he just drag and drop the face, random face from the list, dragged it over the search button or search box, and the system is actually looking through the full history of detected faces and trying to find all the faces that are similar to the one he dragged and dropped to his one.
Yep. So let's try. We see, for example, here our colleague Janka and her appearance since today and yesterday all around the premises. I can also see the detail of the user. I can see the metadata, the time, the date, and exactly the camera ID, which is crucial to trace the user.
This is important. You see her over different days, different locations, she's wearing different clothes, obviously. Some of those images are really far from perfect in terms of facial biometrics. And as you can see, the system has been able to very accurately pick the faces that actually belong to the person, even though we may not know her, which is important.
Here I will also present the feature, the search by image. For example, I have very, very low level quality image just cropped from the video footage, and I can do the search according to this facial image of the user across the premises, as you can see here. And also what we have, This is from the video footage from the airport. We have detected this user just right here. So very, very handy feature if you need to search across a large databases. For the reason we have lowered the threshold score to pretty low number, which means we also really looking for any possible identity that might be matching to the user, and then we can focus on manual investigation in case of reaching more users. So this was the history event. As I mentioned, you can select according to various criteria. You can just focus on the chosen cameras or on chosen watch list. And the same as, for example, you may search only for users that have a mask available or are males or females, women, men, and so on. The same we support according to our age. So just really that simple, and I can search very quickly across the database, across the gallery of stored images. I will just add that also for the GDPR purposes, we support, for example, just temporary storage of the users, or this is completely configurable, how long you want to keep these records. So it can be 24 hours, 7 days, 30 days.
Or if someone asks you to delete their appearance, all you need to do is just take their photo and search the history, and apparently the history shows you all the appearances of that particular person. Just hit delete and basically delete them from the history forever, and you're done.
Exactly. This was the history and search. And we just presented really how you can quickly manage large footages, large galleries of data, and quickly search among them, either to help to investigate your security incident or to the police, which you might be approached by. The last part we have saved for the end. This is a bit different use case, and as Peter has on his slide, the cascading architecture, where you can utilize various inputs. Commonly, people always think about the cameras or the either IP camera, CCTV camera, or the USB camera. What we'd like to also introduce is a bit different concept of the security and identification. And this is very useful, especially in the situations where you cannot, or it doesn't really make a sense to deploy the server, where, for example, you cannot carry always this little guy and from NVIDIA Jetson, or simply it's a security officer in the field where you need to quickly see who is this person, does this person belongs to our organization, is it a suspect, and so on. So you can use pretty much any device. Let's consider the smartphone, a very typical smartphone, where I will simply run dedicated application. I will process the stream from the smartphone. We will be searching for the faces. Once we detect the face, we send it for identification to the server. And as I mentioned, the advantages of such approach is, first of all, you save the network. All you need is just a smartphone and SIM card to communicate with the server that is usually deployed either in the cloud or in the private cloud of the premises in the local network. It really saves the network footage.
And you just need a single image, right?
Yes, exactly. Frame. What we need is just one frame, one image. And let me now showcase this smartphone preview. You see just currently my Android phone. We have this tiny application called SmartFace identification. And I will just choose to identify. And by this streaming, I can simply come to the suspect, tell me who you are. I can check if I know this suspect. For example, I can check it here. I am on the watch list. And Patrick, our assistant, he's not on the watch list, so he will be not notified about the identity. Yes, so this way, of course, we can support various challenging use cases, the same as with the face mask. So the security officers see some suspect, can tell, come over immediately, tell me who you are, and I can check also with the database if you have such person under the same identity enrolled. So very nice usage. This runs on the Pixel 2, which is, I think, like a 5-year-old smartphone. Application is very responsive, and still we can improve it, or we can customize it according to your use case. Another very nice device are these smart glasses I have left for the end. And with these smart glasses, we can preview or we can showcase the identification on the go. by simply using such smart glasses.
So this mirror image is what you see on the monitor, on the display.
Exactly, yeah. Currently, I'm streaming the camera stream. Camera is embedded in these smart glasses. They're running Android 5, so the performance is a bit low, but still we can process the streams, look for the faces, detect them. And once the face is detected, for example, like here, Peter's face, we send the cropped face to the cloud. From cloud, we receive the information about the user, and we can immediately, or the officer can have the glasses directly on his face. It's perfectly wearable. It's not bulky. You can pretty much have it on your face the whole day, and immediately see the information about the user. Like this, yes. So you can see as it's blinking, we process approximately 1 or 2 frames per second.
Directly on this.
Yes, and I see this. What you see currently, this I see in the preview as augmented information in the glass. So we are currently having many POCs, many evaluation concepts utilizing these smart devices, because the idea of saving the network, saving the computing power, that the user doesn't have to carry heavy server or this little guy, is really, it has a lot of advantages, especially in the field. So as I mentioned, you may spot on your CCTV there is a tiny object moving. You consider that is some person just wandering around. So you can immediately send a security officer on premise, and the security officer can immediately stop the person, ask for the identification, and also can see if that user belongs to the organization and what the user claims is true or simply not. So this was the concept, identification on the go, and various devices can be
One more thing, given the architecture that I was describing, distributed microservices, this enables for completely offline wearable use case. So obviously, if you have an internet connection in the field, you have these glasses that talk to the Wi-Fi or smartphone and send it to the cloud, and you get an instant response. But you may also have a situation where you don't really have a connection, you're in the field or the environment with difficult conditions. We can essentially run everything on a mobile device, be it a smartphone, tablet, or a portable edge computing. These also come in the variable form, so you can basically have them on yourself. And that is, as far as the accuracy goes, it's identical with the server-based infrastructure. So we didn't compromise on the algorithm. What you get on the heavy, robust server, you get also on the mobile or wearables part, including the large watch list. So we can literally be completely disconnected and have a mobile car or a wearable setup, and people can still identify a million faces on the watch list without being connected to anything. That's very important, and that's a scalability level that we can talk about.
Exactly. And just to add to the end, this was our last slide. Thank you very much for your attention. And we see that there is some Q&A session going on. So let's focus now on your questions. I can see them here. Maybe Janka, if you can help us to display the questions also to the customers, we see them. Maybe the first question, SmartFace listed in NIST. If yes, please share the rating respect to the accuracy.
Yes, not SmartFace, the algorithm used by SmartFace, which is a facial biometric algorithm by Innovatrix. So if you look for NIST 1 to N, which is an ongoing benchmark, and you search for Innovatrix as an algorithm, there is a latest submission called Innovatrix 007, and you have the respective accuracy of identification for different data sets, mugshots, visa, voter, etc. And you can see that we are approximately in top 10 of vendors with the accuracy and speed of the facial identification algorithm. So, and we keep investing. Innovatrix is technically a biometric company and really focusing on R&D. So not only we have a very well-positioned algorithm right now, we actually have a whole team of people that are constantly improving the accuracy, retraining the model, optimizing it. So we can manage to keep our position within the NIST result table constantly among the top players.
Yes, exactly. So search for 1-to-1 face recognition vendor test or for 1-to-N identification. What I would like to just highlight is also that algorithm in the NIST is one thing, and thanks to our engineering, we can claim that to run the algorithm in reality, it's a bit different if you have a real world setup. So we would like to encourage you to go to innovatrix.com, partner section, just let us know, or sales@innovatrix.com.
This is an important comment, because even if you check out the NIST, and you will see that we have a decent result, the data sets that are being used for 1 to N benchmark are not exactly reflecting this use case. So this data set is called wild, meaning you have zero control over the way the faces look like, and you've seen that in the history, that they can really be difficult to recognize. NIST used to have this data set and performed benchmark on this, but they actually stopped doing so about 9 months ago. So the best experience and feeling of how accurate it actually is to really try out the system. And you will see how incredibly spotty and low-res faces can still be successfully identified against the watch list.
Exactly. So hopefully that answered your question. You can search us under Innovatrix name. Another question is minimum pixel requirement of network camera used with the SmartFace.
Yeah.
If I may answer, we support pretty much all CCTV cameras available on the market that provide real-time streaming protocol, or RTSP stream. In terms of pixels, or simply what should be the minimum face size or pixel size, considering the SDK that is the core of the SmartFace facial SDK, we need approximately 15 pixels between the eyes, which we call the face size. But of course, these 15 pixels looks very different if you have a full HD resolution, or for example, HD resolution, or 4K resolution.
That's why the recommended setup would be any IP camera is fine as long as it's at least full HD. Obviously, you can have a 720p if the face is close enough. But for this kind of deployments where you really have a surveillance cameras far away from the subjects, you would go with at least 1080p, so full HD camera. As Robo said, 15, 20 pixels between the eyes is sufficient for us to be able to detect the face and match it later. And obviously, we can go up to 4K, 8K cameras if there is enough resources for computing.
Yeah. So we do not use typical metrical system. We live in the digital world and the digital camera stream, so we work with the resolution in pixels. And as I said, 100 pixels might be that piece on the HD, but it must be much more tiny in the full HD, which will define also the distance of the user from the camera. But of course, also with the SmartFace, you can easily measure, you can set the right strategy, you can tune the camera preview directly on premise to make sure, because sometimes to go with a too big face size, it doesn't make a sense. Also, when you have a too little, we have the best practices, and again, we would listen to your use case to support your settings. Another question is, can you concentrate multiple faces of one person, therefore increasing the potential of matching capability? I will tell you just yes, and to answer you, I will switch to the demo part, to the watch list. We have deployed the very nice feature called Watchlist Auto Learn, which is very useful for access control. Let me, for example, showcase myself, my identity. The algorithm picks up every day I appear in front of the cameras, the very different appearance of my face. As you can see, even I am sometimes laughing, how do I change over time? And we create so-called master or average template. So it's much more robust. It considers the metadata and the facial landmarks from very different angles. And that gives a lot of confidence to our accuracy, especially in very challenging use cases. So as you can see, face mask on, off. And I have enrolled just with one selfie.
Yeah, the question was about different faces for one person. So this is one possibility where the system will actually learn your appearance as it changes, which is great for repeating faces. But if it's obviously in public security, you don't really know the subject. So you may actually upload multiple faces or pictures about the same subject for the same person. So one record in a watch list would have 16, 20 different photos that you found out. And so that helps to increase the accuracy of identification.
Now, a bit longer question. How does Innovatrix view right wrong? Well, as we were discussing, you can create custom watch list. So it's based on a human decision. Yeah, if you enroll a user, let's say, into the employee list, or if you simply have some suspect, and you enroll this suspect, let's say, in the watch list called suspects or person of interest. So it's managed by the human intervention to say who is right and who is wrong. We are not going this direction. And how does the technology split this? Hopefully, this was answered the logic of the.
This is probably addressed towards the ethical usage of the system, and we are well aware of the movements and initiatives that are pending around the world. We are based in Europe, so we have to be compliant with GDPR. We have our own code of conduct and biometric ethics that we follow, and that actually designs or decides what is the use case we can support and what are the deployments and scenarios where we say no, pretty much because it's against our philosophy. So from technical perspective, you create a watch list. That's a list of faces that you want to be aware of when they appear in front of camera, and those could be VIPs, that could be an Interpol list of faces that are wanted, and you can have as many watch lists as you want, and system will tell you this face in front of camera is on this or that watch list. That's the sheer nature of the system, and obviously misusing this can be very bad for citizens, for certain group of people. But like I said, with the ethical biometrics and with our code of conduct, we are really carefully reviewing every kind of deployment or customer usage. So we are trying to avoid of misuse of the system.
So yeah, and how long, what are the strengths and weaknesses of the technology? What preemptive strikes are we talking about? Preemptive strikes, like especially the common security incidents that can be anticipated, that can be early identified, and this way you can really mitigate the risk. And
the ultimate scenario is where you have a smart city or hundreds of or thousands of cameras, and the technology, thanks to its scalability, can actually process every single stream. So your video analytics solution is basically looking at all the cameras that are deployed out there, and if you set the system right, then ideally we should be notified about something or incident that's about to happen before it happens, because we have the real-time analysis of every single camera, and we can look for certain events, we can look for accidents, we can look for people not following the social distancing, and basically notify the responsible people before it goes wrong. How long more is the tech going to go to market strategy? This is one thing I didn't really talk about. Innovatrix is on the market for 17 years, and we really are doing biometrics, facial, fingerprint, iris, but that's our core business. That's why we even addressed this video analytics solution from the facial recognition and identification perspective, because we think we have something unique, and our ability to identify face from the video stream is comparing to the competition is unique. And so we are not new in this business. We've been doing government projects for document issuance, border control based on facial recognition with hundreds of millions of records for years. And we have been basically spinning off SmartFace, testing it in the field primarily for access control, so we don't do any damage there. And right now, I would say the product after 4 years of development is mature enough in its version 5 that we can finally take a step in the public security, and we think we do it right.
Exactly. Thank you, Peter. Let's move to another question. Can you process texts within the video beside images? Like, I think this is OCR related question. With SmartFace, we focus on video stream analyzing. If there is some text, yes, of course, such part can be cropped, but we really focus on biometrics. And also, when I mentioned at the beginning, we have our custom OCR engine. We use it for processing of the ID cards for the use case of remote identity verification. So we are not going to the direction like, for example, EBI or Kofax with their OCR engines, which is their core business. We have it as a supplementary business for our use cases because we were not happy really with the accuracy.
We have an in-house, very accurate in-house OCR for different use cases. We never actually used that for the SmartFace purpose because there was no need. So we have the means, we have the technology, but it was never integrated. If you're talking about license plate recognition, there's plenty of solutions for this. We could do that, but we really are focusing on our niche, which is accuracy of facial identification.
Exactly. Thank you, Peter. What level of security / encryption do provide for data, templates, and images. Once we detect the face, the algorithm extracts the face template, which is proprietary, and it's a mathematical description vector of your facial landmark. You cannot recreate the face from the facial template. It's impossible. And you cannot process our facial template with, let's say, with the technology from some of our competitors. This way we protect the templates. In terms of images of the faces or the video footages, there are many solutions how to encrypt. We recommend encryption directly on the database level, because if you would like to encrypt directly the images or the templates, you need to consider that you need to always encrypt and decrypt them in terms of, and when you do the matching, which would be slowing down the system. Therefore, we recommend to our partners to encrypt, to provide the security to their hardware, to simply go along with the common security standards. And another question from Azhar: which existing surveillance platform can be integrated with SmartFace platform right now?
By surveillance, I think we mean VMS, so video management system. We have a native integration with network optics and Milestone, but pretty much any VMS platform that can forward the RTSP stream, which is every single one, we can work with. So as long as the VMS can provide us the video stream recorded on live, we are able to receive and process this.
Exactly. So once the security systems VMS supports third-party integration, and very often it does because they have an API or SDK, we can simply connect. And again, we have an integration team. We have done integration into access control systems, video management systems, and so on.
Okay, there seem to be no more questions, and we are
just right on time.
So this was just first of many webinars and series of the education, because we keep adding features, we keep adding functionalities. We listen to our clients. We already have several large-scale public security deployments, so we are going to learn some lessons there as well. We strongly encourage you to reach out to us, sales@innovatrix.com or info@innovatrix.com, and ask for the evaluation version of the software. We have a team that will be happy to assist you with your specific use cases, and we hope to talk to you soon. And hope you will like the solution.
The same from my side. Thank you for your attention, and looking forward to see more questions, more evaluation requests, POCs from your end.
Yeah, there's one more question. Do you provide multi-factor authentication for system logging? We have been integrated with several authentication platforms, and they do provide the MFA. So yes, that's possible.
Perfect. Thank you, Peter. Thank you, Janka. Maybe we can show also the results of the poll. What do you think? Here we go.
System integrator, other.
Okay, so we are very glad that also many system integrators have joined our webinar. And as we mentioned several times, just let us know.
This is useful, thank you, because our messaging and our obviously story was dispersed in terms of sometimes was very technical, sometimes was too high level. So it helps to understand the audience, so you can fine tune the message next time around.
Exactly. And we are also happy that you have some experiences. Therefore, you can at least compare. And again, contact us. We will come in touch back to you very soon. Thank you very much for your attention. We will be closing the webinar now, and have a nice day. Bye-bye.
Thank you.